Okay, so for your project instruction, okay, basically there are two parts you have to implement. The first part is about the language, and the second part is about operation, right? Okay, let me just talk about the language part. The program part can also be done in a similar way. Okay, let's focus on one thing. Okay, let me go to that particular page, and then I'll talk about the grammar. Oh, that's okay. That's my bad. Project instruction, yes. Okay, let's go to the grammar. Okay, this is the grammar for the program. Okay, you can generalize it once I talk about the expression. Let's talk about expression itself. Okay, that's the grammar over here. So there are two things you have to pay attention to, okay? One is called, let me get a full screen. Okay, when you talk about context-free grammar, okay? Okay, so there are two components for each grammar. One is called non-terminals. And the other one are terminals. Okay, you see that word also in the instruction. Don't be too intimidated, right? Back in 2011, which all of you took, right? When we talk about tree, not like a general tree, there's a distinction between internal nodes and leaves, right? So that's how you can think of. Think about non-terminals like internal nodes. And they are the recursive part. They are the way to expand the particular programming string you want to analyze. Okay? On the other hand, terminals are more like the leaves. Okay? Or they are the base cases. Meaning that as soon as you encounter all base cases, then you are done with that particular string. Okay? So now let's talk about how you can see the grammar. So there are two ways I want to emphasize to you, okay? One is about production. Production means given the grammar, you want to generate a string of expression. I'll talk about it. Another way is called parse. So that means given the string, you somehow want to draw a parse tree. Okay, both are useful. Okay, let's talk about it. Let's now go to the grammar over here for expression. You can see over here we say expression is defined as either of the 1, 2, 3, 4, 5 possibilities, right? Either of the 5. Okay, you can see the convention is every time you see capitalized word, that means non-terminals. That means those are the cases for you to expand further the production. Okay, so I would say the following. Okay. What's the top level non-terminal expression? Okay, I'll start with expression. Okay, let's do an example production for you. Okay, let's first talk about production. Okay, I'll start with the top level expression. According to the definition over here, expression can be either of the 1, 2, 3, 4, 5. Let me choose the easiest one. Okay, what if I simply choose integer constant? Okay, so what I would do is I can say, given expression, I can produce integer constant. Are we done yet? Not yet, because we're still dealing with non-terminal. We haven't reached the base case yet. So if you go back here, you can see, follow the definition for integer constant over here, we get to here. So integer constant here basically tells you it's going to be, the first part over here is going to be a pattern. It can be starting with at least 1 digit, which can be 1 or 2, all the way up to 9. And then you can see the star over here tells you it can be any of the 0 up to 9 with 0 or more occurrences. Okay? And if you see red over here in bold, that means they are the terminals. So what can we have over here? So now for integer constant, you can either say, I simply want to have 1. Okay, that's terminal, right? Or you can say, I want to have 2, and the 2 over here basically cover the first part of the pattern over here. And then what about the next part? The next part either can be empty, this part here. The next part can either be empty or get more occurrences. For example, you can say, after this, I can say 2 followed by 3, 4, 5. Right? That's integer constant. Okay? That's your very first production. Any questions? Okay? Basically, the production this way can really help you to think about what are the possible test cases for your project. Right? Okay, let's see another little bit more complicated one. Let's say over here, if I choose to go for, let's say, binary operation. Okay, let's see this particular one. Okay, expression can be defined in terms of binary operation. So what I will do is I'll do another one. Okay, production. First of all, we start with expression here, and then it's defined as binary operation. But notice that there are 2 terminals, the surrounding round parentheses. So these should be included in the string. Okay? So this is how I'm going to draw that. It's going to be some terminal over here, and then some terminal over here, and then inside is going to be non-terminal. So that'll be binary expression. Okay, are we done yet? Not yet, because we still got at least one terminal to handle. So now, how can we expand the binary expression further? In order to answer that question, you have to look at the binary expression, non-terminal. Okay, let's go there. So what you will do is, you can see you got so many choices for binary operation, right? Let me just be precise. It should be binary operation. Okay? Okay, so what are our choices? You can either say it's going to be an expression followed by some terminal, let's say plus, and then followed by another expression, right? So that will give you lots of possibilities. So I would choose, let's say I choose the modulo operation, the percentage sign. So what this will do is, okay, so now I'm going to say this. So the terminal will still be here, but now I'm going to say expression, and also the right-hand side is also an expression. And then the terminal, it will be the modulo. You can see so far we have got into, we still got the 2 placeholders for the expression, right? But now we already got surrounding parentheses and also the middle percentage sign. We are getting there, okay? How can we move further? Okay, now I'm going to speed up a little bit, okay? How can we, so now the job would be, how can we expand this particular expression, and how can we expand this particular expression? They might be expanded differently using different rule. Okay? So now let's say for the left-hand side expression, I will simply go for, let's say, Boolean constant according to the grammar. So what I will do is I'll go for, so this guy here, it will just be Boolean constant. And then if I go further to Boolean constant, it can be either true or false, either of the terminal. Let's say I choose false. Okay? And then over here, I'm going to say false. Okay, so now this part here is terminating, right? But I still got the right-hand side over here that's still non-terminal. What I can do is I can go ahead and talk about the second expression here. Let's do something a little bit differently. Okay? The expression over here, let's say one of the possibilities is called call chain. Okay? It's basically like a method call chain in Java or in whatever OO language you program. Let's say I choose a call chain. Okay? What I would do is over here, call chain. Okay, you can see it's expanded differently. So now looking at the definition for call chain, it simply tells me it's simply going to be name, at least one name. Right? You can see the name concatenated by 0 or more occurrences of dot followed by another name. Okay, so at least you should get at least one name over there. And name, I simply assume name will just be a string. Okay? So now what I will do is, you can see for the call chain over here, I can say it can be either A. Okay, it's an A. Or alternatively, it can be maybe A dot B. Or it can also be A dot B dot C. Okay, that's kind of the production you want to play with. So now overall, what do we get? Okay, let me summarize for this particular one. We got a surrounding parenthesis, and also we got false, as you can see here. And then also we got a modulo over here. And also we got, let's say, a.b.c. a.b.c. So this is a valid string that can be produced by the grammar. However, for this particular project, you got two jobs to do. Number one, you want to be able to pretty print it. And the way you pretty print it is just like this. You would say, starting the round parenthesis, false, modulo a.b.c, and closing round parenthesis. That's pretty printing. The second one would be a little bit more complicated. It's called type checking. So now, I'll give you a little bit of intuition, right? You can dive deeper. Now that we are trying to do modulo operation, so what do we expect on the two operands? They should be both integers, right? Apparently, you can see the left-hand side is not an integer, so you can already decide it's not type correct, right? Type correct simply means you're trying to do a certain operation, or all the operands for the operation actually make sense, right? If you're doing conjunction, then both operands should be Boolean. If you're doing multiplication, both sides should be integer, okay? And one thing you want to pay attention to is the a.b.c. So this is more like a call to the attributes. So this part might take a little bit more time to complete. So that's why I want you to start as soon as you can. I would say for today, I just want to get you comfortable with the grammar so you don't have to be worried about blocking your progress. But for this attribute call, have a look at the example I gave in the instruction. Hopefully that will make sense. Okay? One more thing I want to say before I take some questions from you about the grammar. Let's say we take this particular expression over here. Okay, I'll start a new page. I want to show you how the parse tree should look like. Okay, that's the expression I can generate from my grammar. At the runtime, how do they look like? At the runtime, usually, of course, at the runtime, you have to decide your own classes, right, in order to actually implement this. Oh, I agree. What design pattern should I use for this language here? Should I use singleton? Should I use composite? Anybody disagree? Composite? Yeah, composite sounds reasonable, so you should really try to use composite, right? So as we cover, the way composite pattern works is for you to recursively build out some tree structure. So that will suit this purpose quite well. For this particular one, for example, you may have a class. You may have a class that corresponds to modulo. Okay, I'll just make it up, okay? You may also have a class that's called Boolean constant. And also you may have another class called call chain. And then what kind of tree would you have? So usually for the delimiters like a round parenthesis, you don't have to make them in separate classes. That's something I can tell you. You don't have to. So what you will get is, overall, we are doing a modulo over here. So you can think about the root of the tree is a modulo. And itself has two children because it's binary operation. And the first child should be like an expression, right? In this case, that will be a Boolean constant. And then the right child will be a call chain. Okay, so far we only talk about non-terminals. And you can think about each non-terminal might just correspond to a class that you're going to create. That's a naive solution. But you may want to make it a little bit more perfect as you go. Okay, I would say for task number one, try to get it done as soon as you can so that you have some classes to work from. And then as you go to the second task, you might find that you have to come back often to really refactor your design. That's what I would recommend. Okay, don't spend that much time on task number one. Okay, let me finish this. And then for the Boolean constant specifically, I'm talking about false. And then call chain, I may just have a.b.c. That doesn't really mean you're going to have a class called false, and you don't have a class called a.b.c. That's not what I meant, okay? What you're going to have is maybe in your Boolean constant class, you have some attributes that can store Boolean value, like a true or false. Also, in your call chain class, maybe you have an array of string. Okay, something like that. Okay, as far as the grammar is concerned, right? I talk about production, I talk about parsing. Any question? Yes, go ahead.
So we have like two integers, right? Not the false, because we embed the false as an attribute, not as a class.
Yes.
Yeah. So how do we actually represent the integer like two
integer to integers.
Like
You,
we need two integers, right? Because in the middle we have the module.
uh-huh.
Yeah.
Oh, yes. So over here, okay, number one, this particular string is a valid string. It's grammatically correct, first of all, because you can produce that from the grammar, number one. Number two, it is not type correct. But how do you know it is not type correct? What you have to do is, for your operation like analyzer, you somehow have to traverse this particular tree. Okay, give you a little bit idea. You may want to say, I want to start with the root, which is a modulo. As soon as I know the type of the current object is modulo, I'm expecting the left-hand side should be an integer, and the right-hand side should be integer. I may just have to write a subroutine somehow to figure out what's the type for the left subtree. If the left subtree type is not integer, so that means the whole thing is not type correct. Of course, there will be quite a bit of recursion you have to write for this particular project. And you may want to look at what's the continuation pattern for composite. Okay, you may want to look at that. Okay, questions? Yes? The call chain, yes. Oh, yeah. So over here, I didn't really say that over here. Implicitly, name simply means like a valid string. It can be A, it can be AB, or it can be Jin, just any string. Which brace? Oh, I see. So when you see the round parentheses, if the round parentheses is not in bold and red, so that means they are just to tell you, oh, let me tell you that. Okay, give me one moment. Okay, let's focus on this guy here, name, and then here, right? Let me write it out. It's something like this. We have name, and then we got parentheses over here, and also we got name. Okay, that's basically what you see in the grammar. Okay, first of all, anything that's in bold and red, they are terminals. They should be included in your pretty printer. Okay, so while we are saying this, oh, I forgot just one more thing. I got star over here. Star simply means I can repeat this particular pattern for as many times as I like, 0 or more. Okay, the name can just be, for example, A. Is a string. Okay, and then followed by the dot. Oh, the simplest one I can generate just be A, which means this particular part is simply just empty. Okay, just 0 occurrence. Or I can say A over here, followed by one occurrence of this particular pattern. In that case, I'll say dot, and then B. So that's the second shortest string. Or I can say one more, A followed by one occurrence of the pattern, let's say A dot B. And then I can have another repetition of the same pattern. In that case, I can say dot C, right? So the size of the call chain is unlimited according to the grammar. So whatever you're given, what you should do is you somehow write some procedure to say, starting from the current class I'm considering, should the call chain make sense or not, right? Maybe look at the example I put on the instruction. So hopefully that will help. Any other questions about the grammar? Okay, good. I'm going to make the recording available to you, so you can look at that if you need it.